Good day. This is the PowerPoint entitled Percent Composition, but really it's about empirical formulas. So there's going to be a lot of notes on this one. It does one more type of example related percent composition than everything else empirical formulas. So it says, what's the mass of oxygen 200 grams potassium chlorate? So first of all, you're going to figure out the percent of oxygen in that compound, and then you're going to proceed from there to get the final answer in the 200 grams. You want to have your periodic table handy, and hopefully remember the formula for potassium chlorate is 1K, 1Cl, and 3O. Something you should know from grade 9. So here's getting the molar mass of KCl3. And this question, we don't care about the potassium chlorine once we know this number, the mass of oxygen in the compound, and the molar mass of the compound. Those are two numbers we're going to use on the next slide. So we have our 48.00 grams, and we are going to divide it by the 122.55 grams. So we compared the oxygen to the overall KCl3, and then we make it a percent. So we get a number of 39.17%. What that really means is if we had a 100-gram sample of KClO3, 39.17 grams would be the oxygen. In this case, it's 200 grams, so it would be 2 times that 39.17. But that's not how we really want to show it. So we're going to take our 39.17% of 200 grams, and hopefully in math, you know that anytime you see the word of in math, it really means multiply. But I want to make this a decimal number. So I'm going to make that 0.3917. I'm going to make the of multiply by 200. And sometime this thing should show up. Let's see if it appears. There it is. Whoa. And that will lead us to what the question was asking. And that is how many grams of oxygen are in the sample, and it's 78.3 grams. So you can see I rattled along with 4 sig figs, but the question here gave me 200 grams with a decimal point there, and so that dropped me down to 3 sig figs. I'm going to carry on with the steps for empirical formulas, and then I'll have to shut it down, and we'll go example by example with assorted videos. Well, empirical formulas are the lowest whole number ratio of elements in a compound. And that compound might be molecular, or it might be ionic. Sometimes the empirical formula will be the same as a molecular formula, and sometimes it won't be. C6H12O6, one example of this beastie is glucose. That's an actual formula. It's saying the molecular structure, and if you take by 12, you'll run into this. You have 6 carbons, 12 hydrogens, and 6 oxygens. And it's known as a carbohydrate. Look at that 2-to-1 ratio. You get the wawa out of there. Well, the empirical formula says, hey, let's divide everything by 6. Whoa, that wasn't too helpful. This is going to be a bit better. We're going to get a 1-to-2-to-1 ratio. So a lot of questions, we're going to be going from masses and asking you to work out an empirical formula. And then we have to give you a little more information if you're going to go from empirical formula to a molecular formula. So that's what we're going to look at in the rest of this PowerPoint, which will come in a series of videos. Well, let's look at the steps involved. And really, you've got to follow recipes nicely. Essentially, what we're doing is we're going from mass to moles to get an empirical formula. By now, we should know mass to moles means we are dividing by molar masses. It does tell you it's, in essence, the reverse of percent composition, but most students find it a little more challenging. So, step A, find the mass of each element. Step B, convert those masses to moles for each element. And if you have, well, you're going to have 2 or more elements, Step C says divide by the smallest number of moles of each element. So step C, you're dividing by the same number in each case. And that's going to give you a ratio. And the ratio should give you the subscripts that give you an empirical formula. Now, one of the things is if you run into 0.5, so that tells you to double everything that you came up with. There should be some more steps. There should be a nice step D. If you have an empirical formula, step D applies to finding molecular formula. You only have to do step D if it asks for a molecular formula. So you do step A to C as listed before. And step D confuse people, but it's not that hard. And it may describe it here, but in some ways it's easier to show you with examples. So you need to have the molecular formula's molar mass. That's often given in the question. That's not much determining, but you will have to determine the empirical formula's molar mass, which is pretty easy. And then you're going to see how many times it multiplies in to the molecular formula's molar mass. So you'll be doing that by dividing. You can divide the molecular formula's molar mass by the empirical formula's molar mass, and that will give you what's called a value of n. It will have to be an integer. Step D usually looks like mumbo jumbo until you've seen examples. And once you see examples, then you can come back and look at this step and you'll say, hey, that makes sense. So that's going to wrap up this video. And now we're going to take these steps outlined in the last couple of slides, and we're going to apply them to doing some examples. So the next video will start with this example here.